Okay, so this homework assignment, Unit 8, Day 3, revolves around U substitution. Okay? You have different laws of exponents that you've been doing so far. So the integral of a sum between two things is equal to the sum of two integrals. Okay? You know that you've been able to break that up, whether it's addition or subtraction. Okay? Something else that we've seen is like a constant a was multiplied with some stuff that you could bring the constant out and you would have dx here. That's constant multiple rule. Okay? Other things that are dealing with integrals that you've had practice so far are trig ratios and trig identities. Okay? The backward process of antiderivative, whatever it is that you're given in the integrand. What this revolves around is something called U substitution. Okay? You do have a reverse power rule. You've learned it so far. You have this constant multiple rule. But one thing in integrating that you can't do backwards, that you were able to do forward, is multiplication. So you know the product rule when you're deriving is the first times the derivative of the second plus the second times the derivative of the first. That's product rule when things are being multiplied. When you're taking the integral of a product or things that are being multiplied, there's not a reverse power rule. Or sorry, product rule. There's not a reverse product rule. So you do use substitution instead. Okay? Your goal is to substitute of some kind and grab some kind of U assignment and put as much assigned to the letter U so that you simplify the original integrand. Okay? So this original integrand right here is 5 plus 5x to the power of 6 times 5. You have two choices. You could, if you wanted to, expand this by folding that out. No, I'm not going to do that. You could do it with Pascal's triangle. I'm still not going to do that, okay? It's easier to look at a product and identify that there is multiplication happening between those two pieces. The parenthetic piece times 5. So already I'm thinking my first go-to is possibly U substitution. Okay, you with me? So the analogy that I want to give you is you're trying to use your biggest parenthetic piece that you can find. What's the biggest parenthetic piece that you're going to gobble up, if you will, a lot of this integrand? 5 plus 5x. So U is going to equal this 5 plus 5x. You've gobbled up pretty much most of that problem. You with me? Now, you're looking for the parentheses, whatever's in parentheses, the biggest one. So now I could rewrite this if I wanted to as U to the power of 6. Are you with me so far? The only piece that is not accounted for yet is this plus 5, or times 5. You with me? So you have U assigned, you have it rewritten, but you don't have this times 5 accounted for. Well, in U substitution, the second step is to take that small derivative differential and see what that spits out. The derivative of U is du. What's the derivative of the one to the right? Okay, so here we go. We're going to go back to implicit differentiation. When I said the derivative of x was 1. Now I'm going to say the derivative of x is dx. Okay? What's the derivative of a variable in respect to a different variable? It does depend upon you changing that variable per se. Okay? So if I took the derivative of this is going to be what? Just 5, right? So if I'm taking the derivative, my respect pretty much is going to change now to du. You with me? So now, wherever I saw 5, I'm going to replace it with du. Okay, so let me show you. I might have messed that up just a little bit. It's 5 dx. Okay, so again, let's take the derivative in respect to u. So the derivative of u is du. Therefore, the derivative of this is going to be a 5 dx. It's not just going to be 5 because you're not taking it in respect to x. If it was taken in respect to x here, it would just be 5. But it's not. You're changing it to be in respect to u. So this is going to be like that implicit fill of 5 dx. Okay? Now, in the original problem where you solve 5 dx, guess what you're going to now substitute it with? du. So look at this. This is a lot easier to integrate now because it's just reverse power rule. You changed a product now into one little piece that you can reverse power rule and be done. Okay, so let's finish this off. What's the antiderivative of u to the 6 in respect to u? U to the 7 over 7 plus what? C. It's indefinite still. There are no limits of integration, so it's going to be plus c. Here's the catch. If you're asked to find something in respect to x, as far as the integral goes, then that means its function needs to be written in what? In terms of x. Right now, I don't have something written in terms of x. I have written in terms of u. So ultimately, at the very end, I'm going to have to go back to in terms of x by using my original u substitution and plugging this piece back in for u. There's a lot of substitution that goes on. So where I see u now, I'm going to put 5 plus 5x. It's going to be to the power of 7. And then everything else stays the same as far as the answer is concerned. Now I've gone back to in terms of x, which is what the original problem was asking for, and there's my answer. Okay? All right, let's do another one.